Well, hello there, amazing people. I'm super excited to be here with you on yet another episode of this topic, the mole concept that we've been looking at thus far. It's been a pretty amazing series, and on today's episode, we're going to be looking at the application of the mole concept in chemical equations. Now, how do these things apply when we actually bring them to the concept of chemical equations? That's what we want to look at in today's video. Hopefully, by the end of today's video, you'd be able to tackle a question or two involving the mole concepts playing out in chemical equations. Now, before we even do anything, there's one thing you need to know. If an equation is not balanced, just don't even begin because the foundation is destroyed. The foundation is faulty. There's nothing you can do. So you cannot trust the numbers if the equation is not balanced. The balanced equation is so important in the mole concept, okay? So here is an example of what I'm talking about right here. You can see a chemical equation denoted on the screen right now, the equation of hydrogen reacting with oxygen to form water. The numbers in front, this number, the number 2, this number 2 here. These numbers in front, they are called coefficients. Okay? And there are things that they actually denote or symbolize. The numbers in front tells us how many moles react. So here's what we mean. We have 2 in front of H2. It simply means that there are 2 moles of hydrogen. Secondly, we have O2, okay? Meaning that there is just 1 mole of oxygen. Now you can see that there is no number in front of oxygen over here. That's why we have number 1. And then finally, we have 2H2O. We have that meaning 2 moles of water. So in order to put this chemical equation into words, what we simply say is 2 moles of hydrogen over here reacts with 1 mole of oxygen over here to produce 2 moles of water. Can you see how the mole concept comes in into an actual balanced equation? So the golden rule is to always make sure you use the front numbers, which are the coefficients, like I said. So moving on, we have a scenario playing out. Now, they may ask you or they may give you one substance, okay, and ask you about another. How do you do that? You simply move using something that is called the mole ratio. The mole ratio. And I'm going to show you exactly how that can be done. So we have a step-by-step guide that shows you how this can be executed. The first thing to do would be to convert the given value into number of moles. And then you use your mole ratio and then you convert what you obtain into what they want. Don't worry, don't get confused. I'm going to show you how that can be done. I'm a good teacher, by the way, trust me. So we have this example on the screen. We have the balanced chemical equation over here. And they started off by saying if you have 2 moles of hydrogen, how many moles of water will form or how many moles of water will be produced? So the first thing to do would be to convert the given values into moles. Now, thankfully or fortunately, the value that we were given was already in moles, so we do not need to take that step. The next step says to use the mole ratio. Use the mole ratio. How do we do that? Now watch this. They said if you have 2 moles of hydrogen, so we have hydrogen, how many moles of water will form? Now, from the chemical equation, you can see the amount of hydrogen that is reacting is 2H2, and the amount of water that was produced is 2H2O. So what does this mean? It means 2 moles of hydrogen reacted to form 2 moles of water. So therefore, the mole ratio becomes 2:2. because 2 moles of hydrogen reacted to form 2 moles of water. So did you see how we got the mole ratio? So therefore, we can use the mole ratio to obtain the value for the other element, which is, in this case, water. So from the equation, we know that 2 moles of hydrogen react to form 2 moles of water, H2O. Now the question says, if you have 2 moles of H2, how many moles of water will form? So underneath, we can write directly 2 moles of hydrogen will form an unknown number of moles of water, because that's the question asked of us. They said if you have 2 moles of hydrogen, how many moles of water will form? So at this point, we can cross multiply. So we have 2 multiplied by this question mark is equal to 2 multiplied by 2. So for the number of moles of water produced will be equal to this multiplied by this is 4. So we have 4 divided by 2, which is equal to 2 moles of water, which is H2O. This is the number of moles of water that will be formed. So can you see how this was integrated into an actual balanced equation? Pretty simple, pretty fun. Now, there can be scenarios where they'll just give you the mass of a substance. What you need to do is just to convert that mass into the number of moles. This is very, very, very important. Always do that. Remember, we're dealing with the mole concept, so the mole remains our central focus. Now, that brings us to an all new important topic called the limiting reagent or the limiting reactant, as some other people like to call it. Now, the limiting reagent or the limiting reactant is simply the substance that finishes first. I like to define it as the substance that limits the reaction. In other words, it tells the reaction where to stop. So when the limiting reagent finishes or runs out, the reaction stops basically. So here's a relatable example. Many of you will like food like me. If you have plenty of rice, the rice is plenty, but the stew is very small. Okay? Something like this. Once the stew finishes, most likely the eating, which is the reaction, is going to stop. So that means that stew that was small and finished first is the limiting reactant. It was the one that dictated how much of the food that you ate. I'm sure it's very, very easy to understand at this point. So, how do we find the limiting reagents or the limiting reactants in a chemical reaction? It's very easy, okay? The first step would be to convert all the reactants into number of moles, and then you divide through with their coefficients. Whichever one is the smallest, that is the limiting reagent. Okay, enough said already. Let's apply it to a question and see if we can understand a thing or two. So we have this equation on the screen right now. Okay, the equation of oxygen reacting with hydrogen to produce water. Now, what is the limiting reagent if you have 4 moles of hydrogen and 1 mole of oxygen? Let's find out. So the first thing to do would be to convert all reactants to number of moles, and that has already been done. We have 4 moles of hydrogen and 1 mole of oxygen. The next step to do would be to divide by their coefficients. Okay, so let's write that down. For hydrogen, the coefficient is 2 because we have 2H2 as denoted in the equation. So this big number 2 is the coefficient of hydrogen. That's why we have 2. And then for oxygen, the coefficient for oxygen is 1 because we have O2. The number standing in front of oxygen here is 1, even though we cannot see it. All right, so the coefficient of oxygen is 1, the coefficient of hydrogen is 2, and we are dividing by their coefficients. So for hydrogen, remember we were told that we have 4 moles available. So we divide that by the number of the coefficients, which is 2. So we have 2. Now for oxygen, the number of moles we have available is 1. So we divide that by the coefficient, which is 1, and then we end up having 1. And then the final step says the smallest answer is the limiting reagent. So between 1 and 2, 1 is the smallest. So therefore, oxygen takes the crown of the limiting reagent. What this means is that oxygen is the limiting reagent, and oxygen is the element that determines how far the reaction will go. And when oxygen finishes, the entire reaction will stop. I believe this is easy and simple to understand. Now that brings me to yet another topic called the theoretical yield. Now, as this word um, implies theoretical, something that's on paper. Okay, the theoretical yield means how much product should be formed according to the calculation when you write the calculation down on paper. So in a perfect world, in an ideal situation where no loss occurred, the theoretical yield is what was supposed to be obtained. Okay, so the theoretical yield is actually calculated using the limiting reagent or the limiting reactant. And I'm going to be showing you exactly how that can be done. But before that, here is a relatable example. If you have a recipe for baking cakes, and on the recipe, it was told you that when you combine all the ingredients together, you should be able to obtain 10 cakes. That 10 that you saw in the recipe is the theoretical yield. Because theoretical yield. Because in the process of actually baking the cake, maybe you have some spills, or you lost some ingredients, or one or two things happened, okay? And you do not end up having that 10. Let's say you ended up having 7 cakes. This 7 becomes the actual yield, while that 10 cakes written on the recipe is the theoretical yield. I'm sure you're seeing every bit of what is being shown here. So now that we know what the theoretical yield is, and we know what the actual yield is, it is very useful in calculating what the percentage yield of a chemical reaction is. You see, in real life, when we carry out real chemical reactions, we don't always get the full results. Some of the products are lost, and it's normal, okay, because no one is above mistake. No one is 100% perfect. So in order to get the percentage yield of a chemical reaction, we divide the actual yield by the theoretical yield and multiply it by 100. What do we mean? Well, let's go ahead and check out some questions. We have question number 1, which is a good example. The theoretical yield of a chemical reaction is 10 grams. The actual yield is 8 grams. What is the percentage yield? Well, the percentage yield will be given by the actual yield, which is 8, divided by the theoretical yield, which is 10, multiplied by 100. So this is equal to 0.8 times 100. This is 80%. What this means is that the reaction is 80% efficient. That is the essence of this concept, the percentage yield of a chemical reaction. So here are some exercise questions for you to try out your hands on from all we've been saying since the beginning of this video. We have the first section, which is the basic one. And don't worry, if you're not able to solve these questions, there is another video coming up which shows you the breakdown of all these exercise questions from A to Z. This is just something for you to try out your hands on in the interim. Okay, so we have the next section of questions, which is the intermediate section, and the final one, which is the exam standard questions. So up next in this series, we are having the solutions and concentration in the mole concept. It's been a pleasure being with you all through this video. I hope you got value for it. If you did, please do well to like, share, and subscribe. With that being said, I'll see you in the next video.